Hello, all. Hope you're doing well. So, we are going to continue discussing acid bases and salts. So, in this lecture, we are going to discuss about base. So, we are going to define base on the basis of Arrhenius theory of acids and bases. So, I've defined that before also. So, base, we can say it's a substance that produces hydroxide ion. When dissolved in water or in aqueous solutions. So, KOH, potassium hydroxide, in the presence of water, will give us K plus ions and hydroxide ions. So, all are in the aqueous form. Now, if you remember from the previous lecture, we discussed about basicity of an acid. So, it's a little tricky sometimes to understand what is the basicity of an acid in spite of having many hydrogens in it. So, in the case of bases, it's not that tricky. It's easier to find it out from the formula itself. So if I say calcium hydroxide is there, so calcium hydroxide can release two hydroxide ions and one calcium ion, if you can see this. Again, all are in the aqueous state. So we don't have you can say much, you can say trickier part in the basis. It's very easy to understand. Then we do have something called as common names when it comes to bases. So this potassium hydroxide is commonly called as caustic potash. Caustic stands for base. Sodium hydroxide is called as caustic soda. Calcium hydroxide, I think I have discussed that before, lime water. We even call it as lake lime. And then we have a very weak base, ammonium hydroxide, which is formed when we dissolve ammonia in water. So, ammonia is a gas. So, ammonium hydroxide is very much a weak base. So, common name for ammonium hydroxide is aquammonia. Now, just like acids, we have bases which are going to have certain uses. So, sodium hydroxide is used in the manufacture of soap. We cannot make soap if sodium hydroxide is not present in it. For refining of petroleum, even for paper formation, pulp formation. Then, if we talk about potassium hydroxide, specifically in alkaline storage batteries absorbing carbon dioxide, this reaction is very much useful when we take potassium hydroxide, make it react with carbon dioxide. So if you want to extract potassium hydroxide from anywhere in any particular process, so we can do it with the help of carbon dioxide. So it will react with carbon dioxide to give you potassium carbonate and water. Then absorbing carbon dioxide gas, this equation, manufacture of bleaching powder is for calcium hydroxide. If you can see this. So this we'll be discussing in detail in salts. Like we manufacture bleaching powder. If you remember from the previous or oxidation number lecture, calcium oxychloride CaOCl2. So how do we make it? We actually take chlorine and calcium hydroxide, make it react, so we get bleaching powder out of it. And even calcium hydroxide is very much useful for softening hard water. We even have magnesium hydroxide. This is used as a very famous antacid to remove acidity from stomach. Milk of magnesia also we call it. And ammonium hydroxide is very much useful for removing grease stains and any kind of cleaning window panes. Next that we are going to discuss is characteristics of base. So we know that bases change red litmus to blue, and a base can react with acid to form salt and water, and base can even combine with carbon dioxide to form metal carbonate and water. So you can see over here, this reaction is the best example for this characteristic. Then base is very much slippery like soap, and it has bitter and unpleasant taste. Right? Then we go to the classification. It's very similar to what we did in acids, classification of bases or alkalis. So we have on the basis of strength, on the basis of acidity of a base. Now the term over here is opposite to what we did before. Then on the basis of concentration, concentrated base, dilute base. So we'll start with this one on the basis of strength. So same formula we have to use, that is degree of ionization of alkali we will write. So instead of base, so we'll have certain examples of strong bases which are undergoing complete ionization, weak bases or alkalis which are undergoing partial ionization. So the definitions are going to be same. So I'll be writing only examples. The definition, you can say we can actually write it properly. So strong alkalis or bases and weak alkalis or bases. So degree of ionization of an alkali, that is exactly the same, alpha. So it was for acids, it was for acid molecules. The formula is exactly going to be same, number of molecules of alkali undergoing ionization divided by total number of alkali molecules into 100. That's how you need to write it down. So, but examples matter a lot. Definitions you can write. So, strong alkalis or bases, we have sodium hydroxide, a stronger one, potassium hydroxide. We have barium hydroxide, which is also strong. So, they almost completely ionizes themselves. Like if we talk about barium hydroxide changing into barium and two hydroxide ions. So, this is diacidic base. So, we'll come to that part also. Then we go to weak alkalis or bases. One example I've already told, ammonium hydroxide. So you're going to write like this with a reversible sign, ammonium and hydroxide ions. You can mention aqueous in all the state. So calcium hydroxide is also weaker, and magnesium hydroxide also. So we can say these alkalis are not completely getting ionized. So there is a dynamic equilibrium between undissolved alkali and the ions which are produced by it. So dynamic equilibrium means you can say as soon as ammonium and hydroxide ions are getting formed, so they are getting converted back into ammonium hydroxide like that. So there is an equilibrium which is maintained over here. So we need to when we are when these are getting ionized, so if we try to remove these ions, or you can say, like, they're just getting ionized. So the dynamic equilibrium part we can discuss in equilibrium chapter, but not over here. But you can say as soon as they are converted into these ions, and they can convert back into the respective alkali also over here. Then we go to the acidity of a base. So concentration part, we have concentrated bases, dilute bases. So I'm not going to use this, write it again. So that's understandable. So more base, less water, that is concentrated base. More water and less base, that is diluted base. So on the basis of acidity of a base that we need to discuss. So acidity of a base is, we have monoacidic, diacidic, triacidic. So monoacidic means we are getting only one hydroxide ion. So the examples will be potassium hydroxide, sodium hydroxide, ammonium hydroxide. So over here we are not categorizing strong and weak. We are just categorizing based on you can say how many hydroxide ions a particular molecule can replace. So the definition will be again same. Any molecule of base on complete ionization produces one hydroxyl ion in aqueous solution, and that is what we call mono. Mono stand for one. Di, we can have calcium hydroxide, we can have magnesium hydroxide, we can have barium hydroxide. So all these are diacidic, they are going to release two hydroxide ions. Triacidic, three. So we have aluminium hydroxide, we have ferrous hydroxide. Many examples are there. But we need to remember one more thing about alkali and base. What's the difference? Like, a normal alkalis are soluble bases. So we do have, you can say, bases which are insoluble. And if they are insoluble in water, that means they are going to form precipitates. So we have this ferrous hydroxide. This is not soluble. We can actually get this, you can say, this base to make it react with acid. So then we can have a chemical reaction like aluminium hydroxide. It can react with HCl to form aluminium chloride and water. So then it's those precipitates will be, they will be participating in chemical reaction to form the products. But yes, if you see it in water, then these are also not soluble. Like ferrous hydroxide, these are going to form precipitates, that is dirty green precipitates. And we have ferric hydroxide, they are going to form reddish brown precipitate. We have zinc hydroxide also, which is going to form white precipitate. So there are many bases which are insoluble in water, and they are going to form precipitates over here. So in the next part, we'll be discussing about indicators. That is all for today's lectures, indicators and physical and chemical properties. And then after that, we'll be discussing about pH. And then in the last part, salts. So thank you very much for listening to this video. Please like, subscribe and share this video. Thank you so much.